Okay. Today's lesson with Uncle Hakim, the one and only uncle, the national uncle, is to look at rational numbers. What are rational numbers? Okay, you would appreciate rational numbers as we first look at the definition of rational numbers. You know what a rational number, then you'll be able to be a happy soul. So if you're a happy soul, then you're going to appreciate rational numbers. So I'll begin by defining what a rational number is. A rational number is a number a rational number is a number that can be expressed as a fraction a over b, where b is not supposed to be 0. A and b should be A and B should be relatively prime. A and B should be relatively prime. What's the meaning of the word A and B are relatively prime? A and B have no common factor. A and B have no common factor. In other words, this number should be a fraction that is written in its simplest form, with A and B having no common factor other than 1. So that is the meaning of, and A and B both should be integers. Okay, so A and B should be integers. Then that is fit to be called a rational number. So this is a rational number. So now we are going to look at what is important when it comes to rational number. So we have what we call repeating decimals. Okay, so an example of a repeating decimal is 1.23333. So in this case, 3 goes just repeating. So 3 is a repeating figure, hence this can be written in simpler form as 1.23 with a bar on top of 3, since it's the only number that is repeating. Another number can be 2.56565656. So if you see 5656 repeats, so this can be written as 2.56 with a bar on top of 5 and 6. It implies that 5 and 6 are repeating numbers. So it means it has 1 repeating digit, it has 2 repeating digits. Then we can also have 3 or more repeating decimals. Okay, so then there are those that are just straightforward. For example, we can have a figure like 3.5, just that, but this can be written as it's also a rational number. This is also a rational number. Now, numbers that are not rational, the first one is pi. Pi is not rational. Square root of 2. These are not rational numbers. A number like 1, 3, 2, 5, 7, 0, what? Like that, no pattern at all. This is not rational. So these are not rational numbers. These are rational numbers. Even 1/3 is rational. 5/1 is rational. In other words, what I'm saying is even a whole number 10 is rational because 10 can be written as 10/1. So it can be expressed in form of A/B, and with the only exception for B is that B is not supposed to be 0. So B can be 1. So 10 is a rational number. So 5/1, even 5/7, this is rational because it has been expressed in simpler form. But when you have numbers like these are not rational numbers. And if a number is not rational, it means that number is irrational. That number is irrational. So this is an introduction on what a rational number is. So this is an introduction on what a rational number is. So now we'll progress and go to the next slide and then look at examples. So we are going to have examples. Express. Now this is express 2.56. That is number 1. Number 2, of course, with a bar there. Number 2, 1.23 with a bar. And then number 3, -2.312 with a bar. Okay, I think with these 3, we'll be able to get the concept that I want to stretch out. Yes, we'll be able to get. So express this in form of A/B. In form of A/B. In other words, these are rational numbers that have been given. Now we want to express them in form of A/B. And the restriction is B is not supposed to be 0. So what we do, the first one will be straightforward. So this is our working. Okay. So we get our 2.56 with a bar on top. Take note. You're doing it with your national HANCO. You should be happy. This is your national HANCO, your only HANCO. So calm down. Focus now on what we are going to do. So the first thing that you do, please take note. The first thing that you do is take note of the numbers that are under the bar. So since there are 2 numbers repeating, take note. We shall multiply by a number with 2 zeros, and that's 100. So because of 2 repeating numbers, we are going to multiply with 100 when we start working. So now your working should start like this. Let hex be equal to 2.56 with a bar. Call that equation 1. Call that equation 1. Then you apply since there are two numbers repeating, we shall multiply by 100. So 5 and 6 is repeating. So remember, you can just write to say this is what you have here. So multiply equation 1 by 100. So this is what you have, 2.56, 56, 56, 56, 56, 56, and so on. So this is what you have as your first equation. Now we're saying you multiply this expression by 100. Why by 100? Because there are two numbers that are under the bar, and it means there are two numbers repeating. So this whole entire expression you multiply by 100 so that you can get 100x is equals to 256.56 56, 56, 56, 56, and so on. So this is what you have. So you can write to say my second equation will be 100x is equals to 256.56 bar. Okay, take note, the point is there. Just after the point, that's where you put the bar. So that is equation 2. Okay, calm down. We are doing it with Uncle Hakim. Hope you are there. We are on the same page. Now, having done that, we shall subtract equation 1 from equation 2. So we subtract equation 1 from 2. The normal subtraction, of course. So it will be 100x is equals to 256.56 with a good arrangement minus, like that, put x there, equals 2.56 with a bar on top, Take note, there is a 1 in front there. So please, make a mistake here. Take note. Then you do the usual subtraction. So 56 minus 56, that is which is under the bar, gives 0. Then 6 minus 2, that gives you 4. Then 5 minus nothing, that's 5. 2 minus nothing, that's 2. Then this will be equal to x. Of course, this is 100x minus 1, so that will give you 99x. It's 100 minus 1, that's 99x. So when you have this, now solve for x. So what you have is 99x is equals to 254. Then you divide both ends by 99. Even this side by 99. The target is to make x remain around. Then this will be x is equals to 254 over 99. Yes, you're almost there. All you need is just to check if there is a number that can go in there. For sure, we'll first check 3 can go into 99, but we are not sure if 3 can go into 54. So you have to counter check. Can 3 go into 254? Definitely the answer is no. Because when 3 goes into 25, it's 8 remainder 1. So 3 cannot go 40. So it means this is 254 divides 99 is already in its simplified form. 254 divides 99 is already in its simplified form. Okay, you get me right. 254. So you have just expressed this in form of A over B. You got me right. So that's how you do the first one. Unless there is a question up to that stage, you can leave your question in the box, or you can still get through to Uncle Hakim and find out if this is okay. Okay. So we proceed and go to the next one. So now take note. The second one is a bit different from the first one, in the sense that this other one, it begins with after the point, this other one, after the point, that's where we have the repeating decimal. Take note, after the point, so the second one is like this, 1.23 bar. After the point, that's where we had the repeating number here. But here, there is a number before that. So when you say let x be equal to 1.23 bar, don't call that equation 1 because there is a number here, just that. So make sure that the point moves just right before the repeating number. So what you do is, how many numbers are before the repeating number? There is just one number there. So you are going to multiply this by 10. When you multiply that, it will be 10x is equals to 112.3 bar. Now you can call that as equation 1. You get me right? The reason why we didn't multiply, we didn't call this the first as the equation 1, it's because there was this number just right before the repeating decimals. So ichakubalirapo kubaramu avura 10, you multiply. The reason to have 10 is because there is only one number. If it was like this, 1.2, maybe 5, then 3 bar, would have multiplied by 100 so that we move this point 2 because 2 zeros. Now, because there was just one number, that's why we multiplied by 10. You get me right? Let's follow Hanko Hakim clearly. So the next thing that you do after you call that, now you take note how many numbers are repeating here. Since there is only one number that is repeating, because what you have in this case, you have 10x is equals to 12.33333. Just one number that's repeating. So get that, multiply by 10. Why are we multiplying by 10? Not because we multiplied by 10 here, because there is only one number. There is one number that is under the bar, so multiply by 10. So it will be 10 times 10, that will be 100. Hex is equals to 12.333 times 10. This point will just move there. It will be 123.33333 like that and so on. So your second equation will be 100x is equals to 123.3 bar. The bar should be after the point, and you can call that as your second equation. And the procedure is just the same. The procedure is the same. You subtract equation 1 from equation 2. So the next thing that you do is equation 2 minus equation 1. Then you are going to rearrange them in a perfectly ordered manner. You are going to say 100x equals 123.3 bar minus 10x, you get equation 1 equals, put properly, 12.3 bar. Subtract in a good manner, 3, that gives 0. 3 minus 2, that gives you 1. 2 minus 1, that gives you 1. 1 minus nothing, that gives you 1, equals 100 minus 10, that gives you 90x. Then you want x to remain around, that's 90x equals 111. You divide by 90. Even this side, you divide by 90. So what you do is your x is equals to 111 over 90. You get me right? You get me right? That is it. So if there is a number that can go in 111 and 90, you have to do so. But in this case, there is no number that can go in those two numbers. I think there is 3 can go in there. 3 can go in there. 3 in 11. 3 in 11, that is 3. Remember 2. 3 in 11. 3 in 11, that is 3, remainder 2. 3 in 21, that's 7. Okay, over 3 in there, that's 30. Okay, so 37 over 30. That is in its simplified form. So that's how you answer this question. Any questions? Any questions? This is Uncle Hakim. If you are not clear, replay the video. If you can't get it, call Uncle Hakim. Get to ZStudy. Ask what is the procedure to get to Uncle Hakim. They will advise you. Leave your comments in the comment section. Okay, boom. Let's move to the third and final example. The third and final example. Okay, so allow me to love the first part. Okay. Hope you're enjoying the lesson. This is very good for your understanding. Calm down, enjoy the mathematics that is being done. Very wonderful, wonderful. Okay, it's with Uncle Hakim, so make sure that when you're not comfortable, get to ZStudy, find out. So the third one, so you will find student approach Uncle Hakim. Uncle Hakim, you solved all the examples, but you never did the one with the negative. Say, no. There is no difference. The only difference is this is a negative. So if you want, being a good student, you just say, I'll deal with the negative. Just put the negative aside. Everything start dealing with in the brackets. This is the negative. So the first thing that you do is, as usual, you rate. Knowing in mind that I'm dealing with a negative. So I just say rate hex be equal to 2.312. Don't forget the negative with a bar on top. Call that equation 1. Don't forget the negative. It's a negative value. Then how many numbers are repeating? There are 3. So if there are 3 numbers, what you have is something of this kind, 2.312, 312, 312, 312. So when you multiply in here, the numbers that are repeating, there are 3 times 1000. So 3 zeros, since there are 3 numbers repeating, 3 zeros. Of course, with in mind that it's negative, then hex, that will be 1000 hex. Of course, with a negative in mind as you are working, because the 3 zeros will make this become 2.312. Enough. Oh, sorry, remove the point. Of course, this has been multiplied by 1000. So it is 2312. Okay, let's use a different ink so that people can be happy. And 0.312 repeats. Call that equation 2. Then as usual, subtract the 2. Subtract equation 1 and 2. So what you just do is 1000 x equals 2312.312 with a bar minus, of course, bear in mind that your result should be a negative, minus x equals, of course, there is a 1 in front of x, so don't always forget, 2.312 with a bar. Then you can subtract 1000 minus 1, that is 999. Okay, 999 x equals this minus that, 2 minus 2, that gives 0, 1, 3, 2. Then you want x, you divide 999, even this side 999. But in mind, you know, the result is negative, so x is equals to negative 2310 over 999. Like that. Can a number will go there? So you start testing. Of course, in 999, a 3 can go there. Can a 3 go in 2300? Let's start in 23. Of course, negative In 23, yes, it can go there. Okay. Okay, let's do some mathematics. Let's do some mathematics. In 23 there, it can go in there 7 times, leaving out a 2. So when it goes there times, the remainder is 2. In 21, it's another 7. Then there is 0 there, 0 over. In 999, it's a 3, 3, 3. So it's a 3, 3, 3, 3. Okay. So 3, 3, 3, 3. So it's 777, 770 over 3, 3, 3. That is our figure. That is what we have. So yes, that's it. We are done. So x is negative. So this your is negative 770 over 3, 3, 3. Then this is 37 over 30 in form of AB. This one we loved, you figure out. Thank you for enjoying the lesson, which I fully aware and understood that you've understood. See you in the next lesson, where we're going to deal with irrational numbers. Have a good day.